Alright, let's move on to 2002, step 1, question 5, I think. So, let fx be that polynomial there, okay, really normal, where a1, a2, blah, blah, given numbers, it can be, fx can be written in the form that, well, okay, so it could be factorized, essentially. So minus k1, minus k2, blah, blah, until minus kn are the roots of the equation, right? So, by considering f0 or otherwise, show that k1 to kn, the product of them, equals to an. Okay. So I mean, if they tell you to consider f0, you should do that, right? It's always sensible to follow the guidelines in a step question. Okay. So what is f0? Well, f0 essentially, if I put 0 or in here, what happens? Everything becomes 0 except what? Except the an here, right? Except the an here. So f0 equals to an, but also if I put f0 here, I know that that is also equivalent to k1 blah blah kn, right? So essentially that's proved. Okay, it's probably 1 mark, right? Just consider f0, put it into the two equations, then you'll get the answer. Sweet. Okay. Now, how about the next part though? Show also that k1 plus 1, k2 plus 1, and so on, right? Okay, this is also easy, right? k1 plus 1, then what should x be? You obviously see that the x should be 1, right? The x should be 1. So f of 1, what is f of 1? F of 1 is like that, right? So it becomes f of 1 is 1 plus a1 plus a2 plus blah, blah, blah. Could we see that? Yeah? Plus an. Okay, so make sure we know that. And give a corresponding result for k1 minus 1, k2 minus 1. Well, then you put in x is minus 1, right? So f of minus 1 is equal to, well, 1 minus. Okay, it sort of depends, right? Let's use the sigma notation, shall we? Because why not? Minus 1 to the n, essentially, right? From, what is it from? Minus 1 to the n times an, right? Okay, let's not use n. Let's use k, right? As the counter, where k equals to, well, how should I do this? I suppose maybe 0 to... should I do this? Maybe not, right? Okay, this is really hard to do it in sigma notation. But you get the idea, right? It's just 1 minus a1 and so on, right? Or you could have minus 1 plus a1 minus a2. It's just alternating, right, essentially. It's just alternating. Yeah, it's just alternating. Good. Alright, so it depends on if n is odd or n is even, right? So if n is even, say, then it will look like this, right? It should be plus an. And if n is odd, this is also plus an, though. Yeah, should be like that. Cool, so I suppose we have to split it into n even and n odd. Okay, now we go into the meat of the question. So find the roots of the equation. X to the 4 plus 22x cubed plus 172x squared, 552x, 576 equals to 0. Given that they are all integers. Okay, so in a step question, always look back at the work you have done. Alright, so they tell you to show that the product of roots equals to an. Well, firstly, you know that there are 4 roots, right? This is what you should be aware of. There are 4 roots, right? So probably we could call them k1, k2, k3, and k4. Yeah, k1, k2, k3, and k4. Okay, what do they multiply to? A4, right? If I sub in 4. A4, what is A4? 576. Thank you. There we go. Alright. And when you see multiplication of things, what is a sensible thing to do? You know k1, k2, k3, k4 are all integers, right? Because it says. Right? It says they're all integers. So it might be sensible to think about the prime factorization. Right? The prime factorization of 576. Yeah. So let's go. What is 576? Well, what should they be? How do I do this? So, okay, let's do it step by step. So, okay, I could see that 8 is a factor. So maybe let's take there. That gives 72. Okay, well I could see another 8 actually. So this becomes 2 to the 6 times 3 squared. Okay. Yeah. So we could prime factorize 576. Alright, remember you don't have a calculator in the exam, yeah? You can't press the, prime factorization button you always have on the GCSE calculator. Okay, well, it's not the hardest factorization anyway. So cool. All right. So now I have that result. Now, how about this one? K plus 1. No, K1 plus 1. K2 plus 1. K3 plus 1. And K4 plus 1. What do we think that is? Well, obviously we have what? So it should be A1, A0. So no, A1 plus A2 plus A3 plus A4, right? It should be. So it should be 22 plus 172 plus 552. 1 plus actually, sorry. 1 plus 22 plus 172 plus 552 plus 576. Okay, which equals to something. Which I don't know what this is. Okay, I'm going to cheat with a calculator, alright? Because I have no clue what that actually evaluates to. And I can't really be asked late in the night. So let's see what that is. 1323. Okay, alright, obviously I did that mentally. So now I want K1 minus 1 as well. So let's take that result as well. And by the way, you might want to think about the prime factorization of this when I'm doing the minus 1 version. So this is 1 minus 22, yeah? Plus 172 minus 552 plus 576, yeah? And that equals to something, which again, I'm going to do mentally. Okay, my mental maths tells me that it's 175. Fine. Okay, so again, what are the prime factorizations of these things? Seems like the first one's divisible by 9, so maybe 3 squared times 1, what is it? By 9 is 1, I can't do mathematics, 147, right? 147, okay. So I think there are lots of 3's in here still, so maybe it should be 3 cubed times 49? Yeah, okay, 3 cubed times 49. So 3 cubed times 7 squared, yeah? And for the 175, what have we got? We have 5 squared times 7, yeah? Because it's 25 times 7. Okay. Okay, so now from this information, we could actually already figure out what the 4 roots are actually. Right, so let's have a think. Well, firstly, the roots have to be all negative, right? For obvious sake, right? Because if x is positive, there's no way that thing's going to go to 0. Okay, so K1, K2, K3, K4 have to be negative. Alright, anyhow, all of them are negative, right? So the negative cancels out because there are 4 brackets, right? So no one really cares. Now, let's have a look. So I have 5 squared and 7. So essentially what that's telling me is that the 4 brackets has to be 1, 5, 5, and 7. Well, without lots of generality, right? Has to be, right? I can't have anything else. So what does that imply? That implies K1, or I suppose it has to go like this, right? I suppose. Or no. Does it have to go this way? Oh yeah, it could go this way, or it could go, how should I do this? So, okay, maybe it has to go negative, right? Maybe it has to go negative. Oh, but then K1 is 0, right? But then K1 is 0. How do I do this then? So I need 1, 5, 5, and 7. Okay, anyhow, let's ignore the minus signs for now, maybe. Okay, so K1 has to be 2 then, right? You know that K1 has to be 2. Okay. Alright, so if K1 is 2, well, then you have to think about what K2 has to be. Well, K2 has to be some sort of 6, I suppose. Yeah? Some sort of 6. K3 is some sort of 6. And then K4 is some sort of 8, right? Some sort of 8. Okay, now, does that actually solve the equation? Now we have to have a look, right? So, if I say K1 is the 2, then this actually makes sense, right? Because this is 3. And if I have 6 here, these two give me the 7s. And here, if I put the 8 in, this gives me the 9 here, right? So 3, 7, 7, 9, which is exactly the prime factorization for 1, 3, 2, 3, right? And if I look at the top, if I have 2, 6, 6, 8 here, that actually corresponds exactly to the factorization up top as well, which is pretty cool. Yeah? Okay, so, oh, I'm not sure how the negative comes into play then. That's really weird. Okay, let's just take it for granted for now, right? Let's just say that, okay, minus 1, I don't know, minus 1, minus 5, and minus 7 maybe are the roots. Yeah, I suppose. No, what I'm talking about. No. Minus 2, minus 6, and minus 8. I suppose are the roots. Okay, do correct me if I'm wrong. Not sure what is happening with the negative signs. Because I know that K1 has to be some negative number, essentially, right? Because... Or am I being dumb? Wait. Oh yes, I'm being dumb, right? Yeah, obviously. Because the factorization is x plus K1, right? So the root is minus K1. It's negative K1, right? So all the K's have to be positive. Yeah, obviously. Okay, I'm overthinking this. Okay, ignore what I just said about the negative K's. Yeah? So yes. Negative 2, negative 6, and negative 8 are the roots. Yeah? The K has to be positive. The K's are positive, yes. But the roots are the negative ones. Yeah? So I messed up the K and the roots. Okay. Good. Cool. Thank God that was resolved. So that's about it for the question. Lovely.